Start recording. Share my screen. Okay, so what we are looking at now is file objects in Python. And we said that generally we can open a file using the open function. And the general syntax open, you put the file name. This is if the file is in the same folder as your Python file. Okay. If it's not in this folder, for instance, now our file, day12.py is in LHI, and our text file here is also in LHI. If it's not in LHI, you're going to put the proper path. But because we are in the same folder, we can just put only the file name and the extension .txt. Now, the second argument you provide is the mode. And we talked that the mode could be read mode, where you want to read the content of the file. You could open it in write mode, where you want to write something to the file. You can open it in append mode, where you want to add something to the file. So there's a difference between write mode and append mode. And then we have the arrow plus if you want to read and write. Now, what's the difference between write mode and append mode? When you're writing to the file, it will erase the content of the file and write again. So, like we have our file, you see there are some stuffs in it. If we go and open it in the write mode and start writing, it will override this content. But if we open it in append mode will come and start adding to the end of the file. Okay, so we now read this file, open this file in the read mode, and we read the content using f.read, and we printed the content. And also let us know that anytime you're using this open, you should make sure that you close it. Okay, when you have the open, you have to have the close. So that whenever you finish what you're doing with your file, whether you're reading from it or writing from it, you have to close it to manage your memory properly. So you don't get into some errors that could emanate from not closing your files. You might do it the first time and there'll be no error, but at the time it might generate error and you may not know. It becomes kind of difficult for you to know what's happening. So, but the best thing is whenever you open a file, close it. You have to bear that in mind. Whenever I finish with it, you close it. There's a more efficient way to handle this, but we'll look at that later. That one is using context managers. But we'll not disturb you with that for now. Later, we'll talk about context manager. That's kind of like a little bit advanced. It's not just a foundational topic. Now, we've read it using .read. Another way we can read it is we use read lines. We use read lines. So when we use read lines, let us see the difference, how it reads it. So I run the file again, I save it and run it. Now, watch. It read the file line by line and put it in a list. So if you observe the output, you have the square brackets, you know how list is. Then in this list, our file has, let me open the text file. The first line is hello. Then I hit enter. Then my name is Jane. Now you see hello, and this is a new line character, which is the enter. When you hit enter, you go to the next line. The whole of line 1 form item number 1 in the list. Line 2, item number 2 in the list. Line 3, item number 3 in the list. Line 4. But then each line is showing everything, including the enter, the new line that I put. Even though you can't see it in the file, but there was that anytime you press enter, you added a new line. I went to the next line. So it printed everything out into your list. Okay. this is different from when we read it with dot read. Read it with dot read, you see how it comes out. You see, it just prints everything out neatly the way it is in the file, line by line. So that's two different ways to read. We have dot read and we have read lines. Then we also have read line. This one, just read it. Read line reads one line at a time. So I could read the first line. I can call it again, read the second line. Okay, let's say I need to print. So you see the difference. So the first time we have content is read line. It will read the first line, we'll print it. Then we read again the next time. You read the second line, read again the third time. It will read the third line and so on and so forth. I hope we are following me.
Yes.
So you see now the first time we ran read line, it read only line 1. So read lines, read all the line. Then read line, read them one after the other. Okay, and maybe if you want to work with the lines in the file, you can work with them one by one. And then one difference between this read line one by one and dot read is memory usage. So when you have f dot read, and this, if you're dealing with a very large file, once you read it, it brings all that content into memory. So if it's big, you're bringing a lot. But when you go through it line by line, you're just taking chunks at a time. Okay, I'll read line, this small chunk, I deal with it. I go to the next one, I deal with it. Okay. Then another way we can approach this is using a for loop. Now we can deal with that text file now. We use a for loop. So I can say for line in F. Okay. I can say print line. Let's see how it is. Save and then run it. So you can observe that for each line in F, we printed the line, hello, my name is Jane, like that. So using a for loop, I can go through line by line, and also this is not bringing everything to memory at the same time. You're just going through line by line. Are we together?
Yes. Yes, yeah.
Yeah, and this thing here, we could use list comprehension to put it in a list. How? We can say content is equal to use this line for line in F. Okay, let's save it. So this is, and then we print content and see what it contains. This way, we hope to bring it in to a list line by line. Each line will become an item in the list, but it will not have that new line character. Or maybe we need to do the strip to remove it, but let's run it first and then we'll see. Okay, each of them still has the new line character, so but we can do the strip. Remove it and run. So you see, when you use the strip now, you just have a list, which is each of those lines as items in our list. So these are different ways we can read data from our file. And depending on what you want to do, you determine the one you will use. Does anyone have any questions so far? Okay, so we move ahead.
Sorry.
Yes.
I'm still, I don't know. It sounds stupid, but what I want to ask. What scenarios can we use this kind of programming constructs?
So, sometimes we run some of our examples and then we supply when we are solving some examples, we just supply the input. We just say, okay, this is what the initial list contains. Okay. But in reality, sometimes you don't know what your program is going to handle. You have to write it. And maybe you have a scenario where there is a text file. Maybe another program is putting maybe a log file, right? You can have an application that is logging out its activities into a log file. And then another program is written to read that log file and analyze it for certain events.
Okay.
So maybe you created a device, and your device is like when you talk about Internet of Things, a smart device or something is able to send information to a kind of database for you, and you can download that content into a text file, right? Like I've been in a case where they are dealing with, where they are making some smart street lights. Now, as the device is in the field, it's configured to be logging things that are happening to the device, right? Each action it takes, there's a log. It generates a log file. That log file is like a text file .txt. Now, in that file, you can maybe write a program from time to time to go to that file, looking for certain events. You're just watching if they've occurred. And what that means is you may want to analyze the content of that file, each line looking for an item, line by line. So this is where this kind of thing can come in, for instance. I think that's one I could just think now. Again, we'll still look at how we can pass arguments to our files. Even when we write a file, sometimes from the command line, we've not looked at that. We can pass arguments into the file. Most of what we've done so far is where we will say something like maybe data is equal to eval, and we'll say input, right? We take, say, enter some information. I believe we are used to this.
Yeah.
Now, this is where we get input from the user in the terminal. When I run this, it will ask you for something, you put it and you send it in. This is just one way of getting input into your file. There could be another way whereby this same input, which you want to work with in your file, is stored in another file. And you can pass it at the command line when you want to run the file. We've not looked at that. You can pass it in. Or you can put this information when you're running at the beginning when you want to run a file. Maybe when we talk about working with the command line and passing a command line arguments into your file, you understand what I'm trying to say. So I'm just basically trying to say there are many ways to get information into your program. This was just one way. Another way is you use the command line and send it as an argument. I've not looked at that. So today now we are talking about text files. it could be that what you want to deal with is already stored in a text file. You can write codes to go and pick that file and analyze it. Does that make sense? Or does that answer your question?
Yes, I'm clear.
Okay, for now, let's just learn the skill. Later, you will get to know how you can apply it. Okay, you can pick information, but one place this is used mostly is to read all these text files from logs, from other maybe applications or programs. Even on your Windows computer, there are log files. Things you're doing are being logged somewhere. You get? There are log files. You may not be able to access them, but if you have a challenge, sometimes you will see a notification. Do you want us to report this issue to Microsoft? Say yes. No. Maybe something happened in your computer. Have you people seen that thing?
Yeah, sure, we have. I have actually.
Yeah, something like that. If you say yes, there are some files on your computer that will be sent to Microsoft. Those files are like log files. They are almost like text file, kind of. They're just filled with some kind of text element. Which components of the Windows have been logging data? And when you have a crash, if you send that file to people like Microsoft, they'll be able to analyze the file and see where your system is behaving normally and try to pinpoint where something abnormal happened that led to the crash. Then they will learn from it. And also, they will take a lot of parameters from your computer, a lot. The condition of the computer at that time, what you were even doing, which application was opened. So their own aim now is to use that information and study why your computer crashed. So to analyze it, if they have a log in a text file, you can do something like this to access it and perform some analysis. Okay. Now let's move on from the read mode and go to write mode. So let's say we open the file now with write, and we want to write into this file. So how do we do that? Let me leave this one on read mode. What I will do is I'll open another file. Um, I'm trying to structure how I'll do a copy from one to another. Okay, let's see. So F1 now can be equal to open new .txt. This one now is another file. It's not existing, but I can use the read now to open it. Okay. I open this in read mode, in write mode, sorry. When you open a file in write mode, if it does not exist, it will be created. If you try to open a file in read mode and the file does not exist, it will be an error. But in the case of write, if it doesn't exist, the file will be created. Now, I can say for line in remember, I have to close the file that I opened. So I can say F1 does close. Now for line in F, I can say F1 dot write line. Okay. So for line in F1 dot write line. So what am I trying to achieve? I opened two files. I opened one as a text file in read mode and the other one in write mode. I want to read the line in F and then at the same time write it into F1. So basically what I'm saying, one way you can write is F1 dot write. So this is the write. The other one you have the read. Now we're talking about the write. So let's try it and see. Save our file. Now after running the code, there's no output, but when you look at your folder, you see a new file is created. This file was not there before. So if I click it, what do you see? You see the text from our file has been moved to new file because I did it in this code line by line. So I was reading each line in F. Remember, I said when you're reading, you could do for line in F, and I told you could print the lines. We've done that earlier. So now what I did, I took the line and put it in F1 with write. F1 was not in existence, and I told you that when you open in write mode, if it doesn't exist, the file will be created. You see it was created. And then after it created the file, it took all the data from file 1 and put it in file 2. And now, even maybe I should do this. F1 dot write. This is file 2. But this is second file. This is second file before I perform this operation so that you see the difference. Let me save it and run again. It has run. Now let's look at the file. You can see I first of all put this is the second file before. Now let me add new line so that there will be no clash like this. This is second file. I can put a new line character. Okay, save it again and run. And then we look at the file again. So you can see I first said this is the second file before I now inserted the contents of the first file. Show you that it's then something you see is each time I run it, it rewrites everything, which is what I told you when you're in the write mode. It will pull in the former content and write something else in the file. Okay, that's what's going on with that. But if I use append, if I open it in append mode, it will be adding the content at the file will be growing each time you run the code. So let's do that now and see. So if I change the mode now to append and run it, save it and run again. Let me run it another time, 2 times, then see how the file will look. Can we see it now? .append is growing the file. It's growing the file. So maybe if we are trying to do some log files, we'll be using append. Each time we want to append log something else, it will append. So the file will be growing with more information. Someone may now come later to check the performance of that application that is logging and read the file, looking for maybe a certain event. Okay, can read it. Are we together?
Yeah, sure, yeah, I am, sorry.
Hope it's not confusing. So basically, we've talked about the read mode, the write mode, and the append mode. When you're using the write mode, you need to be careful because if you already have the file in existence and you need the information in that file, it's going to be wiped out. So when you're using the write, But if you want the continuation, use .append. Okay, so, and you see I close both files before I exit my program. Let me clear everything again. Or does anyone have any questions so far? Now, there's another thing which I will chip here at this point. You know, we've talked about print. Another way you can write to a file is print. You can use this one to write to a file. By default, when you use the print function, it prints to the terminal. So when you write your file, you will see it in the terminal. But I can say, for instance, I have finished copy by. Now I am printing this. Normally, this will show on the, let me change this to right so the file doesn't keep going. Let's save it and run. So normally this will be like this. You see I have finished copy in the terminal. I can also put this one into the file. So I can say file is equal to F1. So after I've finished copying, this code still copies from F and puts in F1 here. When I finish that, I will now also add I have finished copy or copying. And I say bye. But instead of this to print on the terminal the way we've seen it now, I'm telling this print to print it into the file. So that's another thing now which you can note. You could be printing your output to a file to maybe save it and see your output later. Because anything you print in the terminal is not saved on the terminal, is gone. But that's when you close, you will not find it again. But now you can print out something from your code and store it in a file. So I save it and run again. After running the second time, you see that the print is there, but it's not printing out to the terminal. Now let's check the file. Okay, it's print here. And then you can see it's because of there is no new line character at the end here. In this our original file, it ended here. There's no next line. So if I want to solve that, I can just put it in this file, or I modify my code so that this one will print on another line. Okay, maybe I do that. I put a print statement and just say file equal to F1. And you know that by default, even if I didn't print anything, this print argument is going to print a new line in the end. So I hope that this new line would be printed into my file, and that will make this print on a separate line. So save it and run again. And then we go and check if that is what happened. Can you see it now? I hope we are together. So that's how it is. We are now reading and writing to file using the print statement, or we use f.write. So I think that's where we'll stop for reading and writing from files for now. Does anyone have any question? Is it clear?
Yeah, it is.
Yes, it's
Uh,
clear.
for me, I was struggling with my network, so I'm yet to get. I just entered at this last phase, but I'm yet to understand it. I mean, when I go through the book, I will take time to look at it. But I'm just following. And
Okay. Ouch. Okay, no problem. That network issue. I believe maybe if you go through it again, you might understand from the recording. And I was asking in the beginning of the class about challenges. No one seemed to have a challenge. Like everybody's just getting or nobody's doing the exercises. I also have to emphasize when you see this thing, like you understand it, even as you're listening, that's true. But if you don't practice it 2, 3 days later, you may forget, you will not know how to do it. If you start doing it and there's a problem, you will not know what to do. But if you take time to do the exercises, you will find out that um, you understand it more. If you're doing it and you make a mistake, you can always correct yourself. Okay. In the chapter, there are also some examples they gave to further address this even before the exercise. It's how you can, someone asks, how can we apply this? If you look at those exercises, you will see some of them. They will tell you to do some analysis. Like one, I'm looking at number 2, say you are given a file called grades.txt, where each line of the file contains one word student username and 3 scores separated by spaces. So this one now is a file of student names and scores. Okay, someone was asking where can we apply this? They now say write a code that scans through the file and determines how many students passed all 3 tests. So this is an example. Student, let's bring it like this. Okay, this is it from the book. Let's talk about write code. Okay, sorry. This is an example from our text. And this is where you begin to see some practical aspects of this. So that you're given a file called grade.txt. Someone gave you that file. It contains the grades of students. You have their name, their username, and then 3 scores that they have. Maybe 3 different tests. Let's, for now, it's only these 2 that are in this file or this example. But you're assuming now that you have many names. Maybe there are 50 students in the class, and these are their performances are written like this. Your task now is to take that .txt file, read it, and then check how many students pass the 3 tests. If the pass mark is, say, 60, you can then do a code that will read this file line by line for line in the file. For each line, you will now analyze it. Maybe you have an empty list of who passed the 3, or you have a count. Whenever you see somebody that passed the 3, you increase the count. If you need to collect the person's name, you can store it in a list. You collect the count, or even put the whole detail of the student in a list. So in the end, you can produce the number of students that passed all 3. You can even produce their names of the student from that file. Also, you can use this .open to handle CSV files. So we've been talking about .txt. It could also be .csv. CSV is now almost like Excel, where maybe somebody give you the Excel of grades of the students, just like this example is talking about. Let's say there are 1,000 students in that file, and they tell you to find all the students that passed. It could even be 1 grade per student, right? Now you can go through it one by one, opening the file and counting. Someone that knows Python can write a script, open the file, go and check, analyze this line, and be able to tell who passed. That's why you need to do the exercises. That's what I'm trying to stress. And then when you have an exercise that's challenging, you bring it to class. If you couldn't solve this one now, you now say, okay, let's handle it in class. We also take time and try to solve it so that you learn. But if we start solving it like this, I start solving it, you're not going to learn. But if you've tried it, you try something and it's failing, you have a challenge. When you bring it and we start teaching it, you understand better. That's why we say study, study. We don't want to use the approach where we'll just come and be solving everything for you. Because it's possible we can say, okay, let's solve this one now. I give you the solution. Bring another one. I give you the solution. But it's better when you try it yourself, knowing fully well that you can open the file in read mode and get the content. You can analyze it. You can get all the lines at once. You can get it line by line. From the class of today, you should at least get understanding how that can be done. And then you can begin your analysis. And even if you want to analyze it and store in a list and print that list into a file and keep, so that maybe tomorrow you can go and look at the result. You can then, use open in write mode. And in the end, take the elements of that list and print it into a file. Are we together?
Yes, we are together.
Yeah, that's why you need to somehow find time to do this practice. That's where you really know it. If not, it will be sounding all good. Oh, yes, I understand it. But when you see a problem, can you analyze the problem and understand how you will solve it? Then come to Python and use your tools to solve it. Because when you see a problem, first of all, the algorithm, this is what I'll do, this is what I'll do, this is what I'll do. Okay, fine. I want to use Python to do it. Oh, I know about the object handler in Python. I can use open and open a file, read the content, and do my analysis, take my result and write it to the file, or even print it using your normal print statement and print it to a file and send it to your professor who told you to do the work. You send him back the result. Okay, so there's one more thing I wish we should just touch today. Should we continue or we close? We've spent like
You can
1 hour.
continue. You can continue.
Can continue.
So let me wait, let this time run down, then start again. Briefly, I would like us to talk about sets. This will help us answer a question that was raised in the last class. Someone said something about duplicates. So we'll see how sets can help us handle things like that. So if we do it in another video, at least it will help me just name the video sets, and I'll call this video file objects in Python. Then the other one sets. So let's just say any question.
Am I permitted to previous question as we are moving?
Permitted to what?
Come with previous, maybe some of the exercises I'll be solving that I didn't get present. Is it permitted?
Yes. It's permitted.
Okay, thank you.
That's how we know that you're